I'm Martín Marqués. I work for Second Quadrant from Argentina. I've been working with Second Quadrant for 6 years already. I've been working in Postgres, I don't know, since 2001. Got the university to migrate from Oracle, from Informix to PostgreSQL. So right now, even all the universities in Argentina use PostgreSQL in their main applications. I don't know if it was me, but I like to think that I was part of that. So I never prepare a slide with my presentation that I know that everybody does, but I just jump straight into the introduction to my talk. So first of all, what we're going to be talking about is transaction ID. I'm going to give an introduction of what a transaction ID is in Postgres and why it wraps around. And then we're going to talk about how we avoid the wraparounds, how Postgres avoids them, and how you can help Postgres help Postgres avoid having to run these special process to avoid the wraparounds of transaction ID. But let's go to the slides. So Postgres has what we call a multi-version concurrency control, which serves so that we can actually have multiple sessions working at the same time and seeing snapshots, consistent snapshots of the database. So there's different visibility isolation levels that we can set. And with those isolation levels, we can see different snapshots, or we can have a different snapshot isolation level of the database. So the default is repeatable, it's read committed. And with that isolation level, what you see is only tuples that have been committed. So if you have a session which started, you inserted a bunch of tuples, and you haven't committed yet, there's another session open, they're not going to be able to see those tuples yet. The minute you commit, if the other session is using read committed, they will see the tuples. With other isolation labels, they won't. What we never see in Postgres is uncommitted tuples, unless they are the uncommitted tuples from your session. So in order to be able to have a snapshot and see only the tuples that you're supposed to see and not the ones that are still out there and not committed, or rows that have been aborted, what Postgres does is it has an xmin and an xmax. So we're going to talk a lot about xmin, not so much about xmax. The xmin is actually stores the transaction ID that inserted that row. So whenever we insert a row, the xmin will be the transaction ID of the session of the transaction that inserted the row. The xmax is going to be the transaction ID in case you delete the row. If you update, Postgres just deletes the row, inserts a new one. So you'll get an xmax on the old row, and you'll get the new transaction ID, well, actually the same transaction ID on the deleted row and on the new one. Something I missed here, but it's in the next slide, I think, is that the transaction IDs are 32-bit integers, and that we only see half of that space. So we use a modular 2 at a 31-bit arithmetic to check if the tuple is visible or not. So we're looking for all the transactions in the past. We don't want to see anything in the future. Anything in the future would be invisible. So just a very short example. I'm going to go very fast. It's very easy to read. Just transaction started. We insert a bunch of rows. And you can see there the transaction ID. It's 576. So if we query the table, if we do a normal query, we're not going to see the transaction ID that actually inserted the rows, but we can actually select those special hidden columns. You know, we can say select xmin, xmax, and the rest of the columns of the table, and you will see the 576 that inserted the rows, and you'll see a 0 in xmax because it hasn't been deleted. But we don't see if it's committed or not. Those are tuple headers. So if we have one session, this is on the same data. We got a new transaction ID. We update the rows. So we updated 5 rows. We open up and we check the data. You can see that the xmin for the 5 rows, the first 5 rows, is still the same because the update didn't hit them. The xmin for the other 5 rows have been updated. This session sees the 5 updated rows. But if I have session 2, I don't see the new rows. I still see the old ones, but the old ones have an xmax which is not 0. The minute we commit session 1, session 2 will see the same snapshot because we have read committed isolation level. So this is like the introduction of of what the transaction ID is, or it's a good intention of explaining something more complex. So the transaction ID is just an ID that moves along 32-bit integers, and when it gets to the end, it goes back to 1 and goes over again and wraps around all the time. So the problem is what happens when we wrap around. So the solution is, okay, let's only use half of the numbers. You know, we have 32 bits, well, let's use only 31 bits, and the other 31 bits is going to be where we will be moving to. So the only problem is that at some point, a very old transaction ID, I mean, rows with old transaction ID could fall into the invisible map, which happened due to bugs in Postgres many years ago. Those bugs got fixed, thank God. But you know, bugs that don't, that were involved with this actually got corrupted data. So it's very important to have the bug fixed, understand what's going on, and actually have good monitoring. So how does Postgres deal with all this half visible, half invisible, and I'm still moving forward? So as I'm moving forward with my transaction ID, the invisible, the lower bound transaction ID where everything is invisible is also moving. So it's like moving in a circle, both. One and the other is tangential. No, not tangential, it's diametric. It's on the other side of the circle. Here was what I was mentioning, that is further ahead. So the transaction IDs are 32-bit integers. But we're only going to see half of those numbers. So that's like roughly above 2 billion, talking in British or English billions, not in our billions, which are a lot more. But you know, you got that amount of transaction ID. That's a big number, right? Or not, maybe. So the problem is not with, you know, like systems that I built 20 years ago, because, you know, we barely used it. We barely got to 2 million in like 5 years or 10 years. But on highly transactional systems, you can actually exhaust those transaction IDs, well, maybe not so quickly, but let's see. If you consume 100 transaction IDs per second average, well, you got 8 months worth of transaction IDs. Then you just exhausted all the 2,147,000,000 and so transaction IDs. If you're using 1,000 transactions per second, which there are, there are systems, maybe even not well designed. You can design it so that you don't consume so many. But there are people that are actually consuming that amount of transaction IDs per second in average. So then you have only 24 days before wraparound. So that's okay, as long as your data is small. We'll talk about that just in a while. So what do we do with the, I mean, we always talk about freezing tuples and running vacuum freeze, but what does it really mean to freeze a tuple? Well, what it means is that any tuple that is older has a transaction ID. When I'm talking about old, I'm talking of the transaction ID. If it's older than the oldest session running on the system or transaction running on the system, so there's nothing that see that tuple, then that tuple is actually visible to everyone that is running on the system. It doesn't really matter if it's session A, B, or C. They all see it because they are beyond the bound of that tuple's transaction ID, xmin. So what vacuum can do is freeze that tuple. In the old days, prior to 9.4, what vacuum did was just change the xmin. So you would actually see a bunch of rows with xmin 2. Those would be the frozen tuples. Starting with 9.4, that changed, and we're actually using some, sorry, we're using bits in the header of the tuple. There were 2 bits, xmin commit and xmin invalid, that one says the tuple is committed, the other says it wasn't aborted. But they are never together, because it's committed or it's aborted. You can't have committed and aborted at the same time. So, well, what the committers do? Well, they said, okay, if they are both on, then this tuple is frozen. So they took away the changing of the xmin column, the hidden xmin column, which is very good because it serves for forensics a lot. When someone hits a bug, like they hit several bugs in visibility bugs in 9.2 and 9.3, 9.2 especially. And when we got a copy, all the information that we could, gather for forensics was gone because vacuum would pass by and just, change the xmin. So we really didn't know when a certain row was inserted. So, as I just said, well, frozen rows are always visible. So we actually don't have to check if the xmin is in front or in which side of the module it is. It's frozen. We already froze it. We put the bits in the header of the tuple. Nothing else. So, but how does this happen? I mean, when does vacuum or autovacuum do it? Well, vacuum does it depending on the 2 values, the second 2 values. Autovacuum will run a special kind of vacuum when a table, the age of the table, in transaction IDs, as I said, goes over autovacuum freeze max age. I guess everybody knows about that, we got some very nice engineers who each time that they have autovacuum running vacuum to prevent wraparound, they just search in Stack Overflow and somebody says it's Stack Overflow. Well, just, put a higher value into autovacuum freeze max age, and they start moving it higher and higher and higher. And one day they have 2 billion in that value. So 2 billion, how much do they have left until wraparound? Like 148 million transactions. So if you already got to 2 billion, I mean, how much do you have left? the other two parameters that are configured in PostgreSQL.Conf. So the first one, you need to restart Postgres for it to take effect. So each time you change the autovacuum freeze max age, Postgres restart. The other two are actually, you can set them in your session. You don't even need to set them in SQL and reload. You can just, you log in with PSQL, you set vacuum freeze table age to whatever. So table age, well, let's talk first about min age. Min age indicates how old a tuple will be if I actually scan a tuple and with vacuum, and the tuple is older than that value, then I'm going to freeze it. If it is freezable, unless there is a very, very old transaction running that is holding back the X-min. The vacuum freeze table age indicates how old the table will be before I actually do a full table scan with a normal vacuum. So if I run a vacuum over a table and the age of the table, that means the age of the oldest tuple in the table is older than vacuum freeze table age, then a full table scan will run over the whole table. We'll talk about how much of a full table scan we're going to do. And it's going to scan and see what it can freeze in the whole table. But we have vacuum freeze, which I guess, who hasn't ever even read about vacuum freeze? Never? Wow. You're starting now with Postgres? Not so long ago. Okay. So vacuum freeze is just a special vacuum which just sets vacuum freeze table age and vacuum freeze mean age both to 0. So basically what it's going to do is it's going to scan the whole table. It's going to freeze everything that it can freeze. Doesn't matter. It's going to, if there's no other transaction running on the database and you run that on a table, it's just going to set everything to 0. Put everything in the current transaction ID. So it's like starting fresh with the transaction ID counter. So you'll see that the age of all of the table is 0 if you check. So here's a very, I'll say just nice, nothing else, query to check for, this one checks all tables, gives you the name of the table, the age and transaction IDs, and, well, the size. So it's ordered by the age of the real frozen XID. You can see that this is the special column that holds the age of the whole table. So that actually means that there is a tuple in, for example, in PGProc that is 8,029 transactions old. Well, that's because this is I created a cluster, and those are, you can see that they are all catalog tables. And I've been already fooling around with the real table. So if PGProc was the first one, but it was the first one because it's the biggest, not because there's nothing else there, because then all of them have the same age. But if I vacuum it, if I vacuum PGProc, then PGProc disappears when I run the query again. That's because the age is 0. And this is another nice query where this is with the age ascending instead of descending. So I'm seeing the 3 tables that I have vacuum freezed. This is a user table, and the other 2 are PGProc, PGStatistic. We still haven't got to the fun part. Yeah, this is just, we're still in introduction freezing. That freezing is like sort of introduction. This is another interesting query to use for monitoring or something, but you actually don't need it. There are already nice monitoring tools out there that you can download and use to check freeze. So this will just tell you globally all the tables, what's the age of a database for each database you have. So I'm actually querying PG database, and I'm grabbing the age of that would be the database frozen XID. So that's like the oldest of all the tables in a particular database. So you see that we have Postgres and Martín, both have the same age because, well, they are the original catalog tables. So what would the issues be with freezing? We've been talking about running vacuum freeze, autovacuum. We spoke that autovacuum actually freezes tuple. It scans whenever it gets over, when it gets over autovacuum freeze MAC page, it will actually run, well, it's called a vacuum to prevent wraparound, but it's actually a vacuum freeze. So what would the issues be? Well, first of all, if you have a concurrent system with lots of sessions connected at the same time, you have, well, especially if you have long-running transactions, report queries, prepare transactions, there's a lot of different ways that you can hold back the XMIN from it. Hold it back so that vacuum cannot freeze or clean up tuples. So it's only going to clean up, well, not only clean up, but also freeze tuples that are visible for all the backends. So if all the backends close and you run a vacuum freeze, then, well, you're going to clean up everything. But if you have sessions that are open, connected, running a transaction or running a query, whatever, then, well, some tuples will get frozen and some won't. Also, 9.5 and 9.4 and 9.3 and anything older, a vacuum freeze or a vacuum where you had table age set to 0 would do a whole table scan. So it would scan all the pages looking for tuples it could freeze. In 9.6, there was a very nice patch committed by Robert Haas. Added into the visibility map one bit that is the all visible bit. So, and I hope Alvaro doesn't correct me here, but the all visible bit is basically says all the tuples in this page, in the 8K page, are visible. So when all the tuples in the page are visible, the bit is on, else it's off. So now, if vacuum runs, vacuum freeze, and you need to freeze all the tuples, if you find a page that has the all visible bit on, then, well, you don't need to scan that. You know that everything is visible, it's all frozen, let's move on to the next one. So that brings a very nice enhancement. So let's talk a bit more about autovacuum. And what's the difference between a normal autovacuum running and autovacuums to prevent wraparound? So the normal autovacuum is actually a very nice one. It cancels itself if it's blocking any user level backends. So if you have your application that needs to acquire a lock, and autovacuum is actually running a vacuum, and it's holding a lock that prevents the other lock to acquire the access to the object, then autovacuum will realize that and just cancel itself, or commit suicide would be a nice one. It disappears, and then comes back later. So it's not like, okay, I'm not going to vacuum this table ever again, but it will come later. Now, whenever we run an autovacuum to prevent wraparound, that is, when the age of the real frozen XID of the table is larger than what we configure in autovacuum freeze max age, that will not cancel itself. You can terminate it. You can actually run select PG terminate backend, grabbing the process ID from PG stat activity, but it will terminate, then come back later, and come back later, and again. And it won't cancel itself if there's another transaction from the application that needs to do something over that table that requires a higher level lock that conflicts with a vacuum lock, which is a share update exclusive. No, share update exclusive. Yeah. So, autovacuum to prevent wraparound will start, and that's another problem, that it starts at any time. It's like autovacuum is checking tables to run normal vacuum, and all of a sudden it sees this table that has a real frozen XID that is very big. It says, okay, let's run a vacuum to prevent wraparound here. When, well, it happens in business peak hours, like when you're like this, not here, you're like up here. You say, why now? And you cancel it, and you cancel, and then you just put a cron that runs canceling whatever prevent wraparound there. No, that's what sysadmin do. That's what I would have done like 15 years ago if it happened. So the other thing that administrators do, I've seen this so many times, is, and I'm sure they found it in somewhere Googling, is they start to increase autovacuum freeze max age. Because, well, yes, it's true. If you increase it, you have more time. Because autovacuum will say, oh, it's not bigger than autovacuum freeze max age anymore. Now it's smaller, so I don't need to freeze this table. I'm okay. So he leaves it and goes to another table to work. But then, this just delays the work that has to be done by autovacuum. So you actually have to have autovacuum do its work, finish it, and move to another table. You don't have to say, okay, do it another day. Well, you could, but we'll talk about that later. Questions so far? Everybody understands autovacuum? You did a great job, Albert. He's the creator of autovacuum. Well, he's the one that committed into core. And in a moment we'll see when, because I have a slide. Right there. So, on Postgres 8.1, autovacuum was committed into Postgres. Before it was an extension. An extension? Yes. Yeah. It was called PG_autovacuum. And I never used it, really. No, I never used it. Well, I had a bunch of scripts that ran vacuum at different hours. Some weird things that sysadmins from year 2000 and before did. But when it first was committed, it didn't have any capabilities for freezing, and it was actually disabled by default. So in 8.1, autovacuum was there. You could enable it. It would clean up the tuples, but it didn't have all the freeze capabilities. So even if today on 9.4, 9.5, 9.6, 10, or 11, or 12 in a couple of months, or 12 beta if you want to test it, you can disable autovacuum. You can say, okay, autovacuum, you can disable it. You can disable it for a table. You can disable it for the whole cluster. Doesn't matter. You'll get really bloated tables unless you're running manual vacuums. But it will always come up when there's a table that needs freezing. So whenever a table needs to be frozen, autovacuum will come up even if it's disabled, but not in 8.1. In 8.1, there was no capability. I mean, autovacuum did not do that work. So we had a customer that came to us with an 8.1 that was about to get into wraparound. Or actually, no, they actually got into wraparound. I'll show you the message and how to get out of that later. But it was really funny when they said 8.1. We had to actually do a checkout of the source code, start compiling, seeing tons of errors because we have newer GCC installed and the old versions of Postgres do not compile with the modern GCC. So Alvaro said, well, you have to do this trick and this other. And okay, it compiles. Now let's test it. Especially because nobody remembers all the options, and if the query works, you're going to send someone a query to, gather certain information. And what was PG class like back then? It's like, I don't remember. It's like, this is ancient. I was like a teenager. Well, not teenager, but you get me. I will say no more. Well, I will say it again later. Please, please, please. And as the slides go on, you'll see that it's super beneficial. You'll see that all the progress that has happened since 8.1, because I'm not going to talk anything before 8.1. Yeah? But since 8.1, 9.6, well, 10 and 11 have other things that could help us here. And 12 has a bunch of other new features, very, very interesting with vacuum. So please upgrade. So, oh, this one was a nice title up there. Do I have to wear a red cap? It's a red cap, not a red hat. Red hat is red hat. Okay, that's, but it's blue now because it's owned by IBM. So they're going to move to the Fedora. That's blue. So, what's the problem with autovacuum? Well, I mean, why do people actually, if we have autovacuum, we have it enabled, and why do we end up with, at some point with autovacuum to prevent wraparound running for a whole week or 2 weeks or more? Well, the first reason is that the default parameters that come with Postgres are really not aggressive enough. They are really poorly aggressive. Well, I wouldn't say poorly aggressive, but it's like it goes really slowly, tries not to use too many resources. And those parameters were set 15 years ago, the defaults. So we're talking about performance parameters for hardware from 15 years ago, where you didn't have SSD, and not even the HDDs were that fast. The other thing that you would have heard from Alvaro is that autovacuum has a whole process of how it cleans up tuples, where it has to scan for dead tuples, then goes to the indexes, searches in the indexes for the dead tuples, cleans them up, then goes back to the table, cleans up the table. So there's back and forth. Well, if your table is quite small, it's not a problem. It's just going to do, and I'm gone. If your table is big, well, I'm going to scan the first part, then I'm going to go to the indexes, then I'm going to go back to the table, scan a bit more, then go back to the indexes, and back and forth, then you got an autovacuum running for 16 days. So, big tables exasperate the two items from above. So if you have a really big table, 500 gigabytes, 1 terabyte, I've seen even bigger, 2 or 3 terabyte table. Well, with the default parameters, the cost parameters that come with Postgres, well, it's going to run for a very long time. So, and the other is if the table in question has a lot of indexes. So if you actually have a really big table, it's very likely that you're going to put like a bunch of indexes in there, so you never have to scan the whole 2 terabytes of data. So both of them make autovacuum, I'm not going to say slow, but run for a very long time. So we don't need. There was a talk just like an hour ago. It was like autovacuum is not your enemy. Well, making autovacuum more aggressive is actually good. Because why? Because it finishes the work quicker. Finishes, the logs go away, and it can go to another table. If you have autovacuum running for 16 days, it's 16 days where there's a backend that can't do any other jobs. If you have 3 tables, you have to run a vacuum to prevent wraparound, then you're running vacuum to prevent wraparound, and you're not cleaning the tuples. So it's very important that the vacuum runs as quick as possible. Finishes the work very quickly. Now, if you have a terabyte table, that's going to be complicated. So these are the 2 commits that we have in Postgres 12. This one is going to change the value of vacuum cost delay. So we have, there's 2 parameters which are very important. One is cost delay, and the other is cost limit. So cost limit just is the limit of the cumulative cost that vacuum has. So vacuum has different costs if it hits a page in shared buffers, if it has to bring it from disk. So depending on where the tuple came from, if the page is dirty, it has different costs. So while it's scanning the table, some pages will be in shared buffers that has a very low cost. Then if it has to bring it from disk, that has a very high cost. When it gets to the accumulate of those costs, gets to cost limit, which is not here because it's not part of this patch, then autovacuum will sleep for vacuum cost delay. So what this patch does is it just lowers it from 20 milliseconds to 2 milliseconds. So what does that mean? Somebody knows? How much faster? Yeah, well, I'm not going to say 10 times faster, but it's going to sleep 1/10 of the time each vacuum cost delay. So each time it has to sleep, it's going to sleep only for 2 milliseconds instead of 200. When you have a really big table and you start to analyze how much it's going to sleep, you might end up saying, okay, I have, for this table, the amount of pages I have in this table, if it has to scan the whole table, it's going to sleep for 2 days. And I'm not joking. You can, with the default parameters, not with the new defaults. The other, from Masahito Sawada, adds index cleanup to the vacuum. It's a new option for vacuum, and you can actually set it in. You can set it also in PostgresConf, and you can actually also alter a table and say, okay, this table I want index cleanup to be false. So what does index cleanup do? It just avoids going for the indexes when you're vacuuming. So I vacuum the heap, I don't touch the indexes. So the indexes will be bloated. But we got reindex concurrent in Postgres 12, so who cares? So I just rebuild the indexes. As long as I get my tables clean, unbloated, and frozen, well done. Don't take that so literally. It's not like that, but sometimes it can help. So it comes handy. So what can we do in the meantime? Because this, you see the dates, right? March 10 of 2019. April 4 to 19. So these are new patches from this year. So this is going to be in Postgres 12 in September. It's not now. If you're running Postgres 11, which is the last stable version out there, you don't have this. So, well, what can we do? Well, configure autovacuum in your system so it's more aggressive. You know, lower the delay so each time it gets the cost limit, it sleeps less. Well, you might also want to increase the cost limit. So the default is 200. So it means that whenever the cost of picking pages, that vacuum has to bring pages or from shared buffers or from disk, or it finds a dirty page, when it gets to the cost of 200, it has to sleep. Well, you can increase that. So that, well, let's say 500, 1,000. So instead of sleeping when it gets to 200, it keeps on going until it gets to 1,000 or even more. Test. These parameters require only a reload. You don't have to restart it, so you can actually test it. If vacuum gets too aggressive, you see that the I/O is, you know, spiking up when autovacuum is running, which I don't think it's going to happen, but you know, I mean, depends on the workload. Then you can, you know, revert the change, or you know, maybe you got too aggressive and you want to get a bit lower. Don't do the full revert and go to. What happened? Everybody's here. Oh, it died. That one has been dying all day. Well, I can talk and everybody's going to still listen all the BS that I say. I can say BS, right? Nobody understands that. I do. You did. So, well, I know. So one of them was, well, make autovacuum more aggressive. Another that you can do is, well, if you have very small tables, it's not a problem. You know, scanning a whole table that is just, you know, a couple of gigabytes is fairly quick. But if you have something of 500 gigabytes, then, well, we got more problems than autovacuum. But autovacuum is going to be a problem, you know, scanning the whole 500 gigabytes or bigger. So we can partition. So with the new partitioning that we have since Postgres 10, which is much better in Postgres 11 and even better will be in Postgres 12, we can actually have smaller tables, which are partitions of the bigger one. So we had 500 gigabytes. We can, well, I don't know, build partitions and have 50 subtables, you know, child tables, each of 10 gigabytes. Come on, it's a division. 500 divided 10. I know I'm a mathematician, but no, I said 50. 500, it's 10. Did I say 50? 50. So it's 10 gigabytes each. So 10 gigabytes is, well, okay. These two actually, I'm talking about autovacuum and freezing and stuff like that, but these two you should actually do it regardless of this talk. If your table is really, really big and you can find a way to partition it, it's a good idea. The new partitioning system is very cool, very fast, very fast on inserts. It also redirects your selects. So if your selects all go to one child table, you're not going to have to scan all the table. You'll go there. Also remove unnecessary indexes. That's like, always do that. Doesn't matter. Check your indexes. Which are the ones that you don't use? Throw them away. They're useless. They take space on disk, and they make your system perform bad on inserts, updates, and deletes. Having more indexes is great when you have a data warehouse where it's not an OLTP system, but when it's an OLTP, well, it kind of sucks. Well, please don't run without a vacuum off. Don't do that. It's, I mean, unless you're running manual vacuum every, whenever you need it, and very often. But it's, well, if you're actually running vacuum very often, manually having autovacuum on doesn't, autovacuum is not going to do anything. So this is the part about what we do with autovacuum in the meantime. There's other things that we can do, which is, well, run preventive vacuuming. So what is that? So I showed I think, or is it here? I think I showed it. No, here. So this one is the other way around. This one is the one I want to see. So we have this query where we're actually, ordering by the age of the rel frozen ID. So we could actually check this, and whenever a table has this really old age, we could actually go in and vacuum in it at a time where the system is actually under low load. So what else can we do in the meantime? Well, first of all, apply all the vacuum changes that we just talked about. And as I just said, during the low load hours, run some kind of preventive vacuuming. So just query PG class like we just did in the other query that I just showed. Look for tables that are really old, have a really large age in transaction ID. Basically the ones that are very close to autovacuum vacuum freeze age. There we go. And run a vacuum on those tables. Just get the ones that are really old and run a vacuum with vacuum freeze table age set to 0. So vacuum freeze table age was the one that, what did I say it does? You can say. It's the one that does the full table scan. So we want to scan all the table and freeze everything. If we leave it with the default value, which is something like 2 million or 50 million, is 50 million, the default. So it's only going to freeze, no, it's only going to scan pages that have tuples that are older than 50 million. It's not going to scan the whole table. So if we've set it to 0, we're saying, okay, this table is close to a vacuum to prevent wraparound by autovacuum. Now, autovacuum is going to eventually and very shortly run a vacuum to prevent wraparound. And that could happen when? Well, in the middle of our business hours. So we can actually run at night something that does the vacuum, does the full scan, cleans everything, and we're good for another 2 billion transaction IDs for that table. So we can do this for several tables. And obviously, we can actually analyze the possibility of even being more aggressive because, well, it's low load hours, nobody's using the system. So let's really make autovacuum work at full speed. Well, not full speed, but close to full speed. Lower load hours doesn't mean that nobody's working. It's just, we're not using all the resources of the system. It's like this is business. Then we're going a bit down because, some people go drink a beer and they're not with their cell phones working or sitting on the laptops or whatever. And then it comes back up the other day. It's not that nobody works, nobody is accessing the database. It's not that you need to shut everything down. It's just, you have more resources to use. You have more I/O, you have more everything. So this will, as I mentioned, will prevent autovacuum from launching those vacuums to prevent wraparound in the middle of the day, obviously. Questions before I go to the next one? Nothing? Wow. I'm getting good at this. Well, this is a query I sketched that you can actually use because this slide will be available. So it's going to get your table. You're going to get actually the XIDs left until you get to the threshold of autovacuum, vacuum freeze age, and the size of the relation. So we have table, how many XIDs we have left, and the size. We're querying from PG class and PG namespace, and I don't know why I'm joining with PG namespace, but I guess that's, like, you copy and paste that everywhere because you want the namespace, but it's actually not needed because we have this very nice cast to reg class that we can use with all the OIDs from PG class, which is very neat. You should use this. It's excellent. So with this, you don't need this. Do I? No, I don't need it. Just checking if there's anything left there. And I only want, I want tables. So I check that the rel kind, which is one of the columns of PG class, is relation, R. And then we also filter by the age. So we check that the age of the table is older. I do an int 8 there because I need it for this comparison between these two. Especially because autovacuum freeze max age is normally 200 million or bigger. Sometimes it's 2 billion, as I told you. It shouldn't be, but it can be. Actually, Postgres doesn't let you set it above 2 billion. That's, I think we should lower that, but I don't know. Well, later I have like an item that will just throw all this away. I don't know why I'm talking. I should just, said we got coming, so don't bother with all this other thing. So what I'm doing here is I'm getting the current autovacuum freeze max age. This current setting just looks at the current setting of that parameter, and I multiply it by 0.9, which is, I'm like lowering it to 90% of the value, so that I'm actually getting tables that are not above this value, but I'm actually, very close. Anything that is 90% of the value, I'm getting all those tables. I'm also getting tables that are above them. I'm getting everything above them. Even ones that are being vacuumed to prevent wraparound right now. And I order them by the XID left. So first tables are going to be the ones that I need to vacuum earlier, but I should vacuum all of them. So you run this query, you gather the tables, and, well, you're done. Just vacuum them all, just using the recipe that was before. It just said vacuum freeze table age to 0, and just run a normal vacuum. You can run a vacuum verbose if you want to have more information, and just let it freeze everything that it can. Another interesting feature, because you could actually have an autovacuum running over the same table that you're trying to vacuum, you can set lock timeout, so that you can set it to 5 seconds, something like that. So if you run a normal vacuum and there's already an autovacuum to prevent wraparound, then that vacuum will just wait 5 seconds and then timeout, and you can go to the next table, which is also very neat. That is available in 9.3. Yes. 9.3. No, 9.3. 9.2, I had problems with that. So, what happens when everything fails? The system administrator went to sleep for 8 months. No, 3 years. He did nothing. He didn't have monitoring. He didn't have anything running that would tell him, you know, get a pager duty and, oh, we're getting close to wraparound. We need to do something. Let's Google. Well, you get to something called, well, it's not an emergency shutdown because Postgres is not going to shut down, but you're going to have to shut down. Once upon a time, I consumed 2 billion transactions, and what happened? Well, when you're that close to wraparound, there's a threshold. We were looking at it with, well, actually, I was looking at for it in the code and couldn't find it, and I asked Alvaro, and he said, well, it's kind of tricky. You actually have to, right? But I think it's like the one that says that actually does prevents the wraparound, that actually does the shutdown, or that tells you to shut down, is like 2 million transactions from wraparound. And I think the other one is like 20 million from wraparound or something like that. 100 from wraparound, from the 100. And the other one is very close, but it's, you know, it doesn't get to the 2 at a 31. So whenever you're 200 million transactions to wraparound, you're going to start seeing these warning messages in your logs. It means that the sysadmin was not looking at the logs. Shame on him. And once you reach the wraparound of the system, which is not the actual wraparound, but it's, you know, just close enough that you shouldn't be doing anything there, well, Postgres is just going to reject from giving you any new transaction ID. So what does this effectively mean? Anybody know? What happens if I can't get a new transaction ID? No. You can't do any DML, any changes. You can't run begin. You can still select. So you're essentially in read-only mode. The system, the queries that come in with select, they will run, but whenever you try to do something that modifies the data, you're gone. You just get an error like, well, not the first one, like this one. Database is not accepting commands to avoid wraparound data loss in database, and, well, the name of the database. And you have this beautiful hint. I mean, this is like beautiful. I don't know why they call you when they get into this state, because this is all you have to do. You have to do this and read the Postgres manual, or you actually can just do man Postgres or Postgres -- help, and it's going to tell you how to enter into the database in single user mode, and then just run a run a vacuum over the whole database. So you're going to be down for a while if your database is really big. But, well, shame on you for not vacuuming before. This was the warning. This is what you're going to get in the logs way before you get here. You get a warning. It says that your database is, well, it's going to got there, which I think is too little now, that Andreas gave me the right value. Just take 1, 2, 3, 4, 5, 6, 7, 8, 9, and I said, is that enough? No, I think, well, no, it's not enough. It had to be just a nudge higher. No, it's good enough. It's below the 200, so it's good enough. Yeah, I had a 0 on the back, and then I just said, oh, this. So if you get this in your logs, start thinking of vacuuming. If you get this in your logs, you need to do this. Yeah, and actually, depending on the version you're in, you might also need to, drop replication slots and stuff like that. Anything that is holding the Xmin back. It might not be necessary, or it might be, but something is holding back the Xmin and not letting vacuum freeze older tables. So something is preventing vacuum from moving forward. So it can be a prepared transaction. It could be an unused replication slot. It could be that somebody opened a transaction, did begin, ran some query, and then went home, and then got fired. And the session is there open, and nobody wants to use that computer. And that's the recipe. Don't look it in Stack Overflow. It's here. Run it like this. You need the single has to be the first parameter. So you have to do Postgres, single, the name of the database. Well, that can be, you can put Martín and then where your PG data is with the dash capital D. But the single has to be first. That's for sure. You'll get an error if the single is not first. Well, then it says, Postgres. Now here Postgres is running. So you shut it down. You started with this command. And this is going to be the only shell connected to the Postgres database. Nobody else can connect. There's no way to connect over. It's in single user mode. And you run a vacuum, and it's going to vacuum the whole cluster. It's going to clean everything up. When it finishes, you just, Control D or whatever to exit. Control C also, I think it works. I use Control D because Control D is, what is Control D? End of file. So and the file is end of the connection. And you can start Postgres again, and you're going to be happy. Or not. Or fired, maybe. I don't know. I don't know if people get fired for this, but I've seen people run into this twice. And then they come and complain on Twitter about it. I told you last year. Postgres sucks because you suck. How much time do I have?
One more time.
Okay, but I'm in my conclusions, so I'm gonna, and my conclusions are just everything I said so far, but resumed in 2 pages. So before 8.2, we had to run manual vacuum to freeze. I told you about the 8.1 customer that they had an 8.1 on Windows, no monitoring. I think nobody ever really logged in or anything. And one day it wasn't working, and somebody said, "This application is not working." 9.6, vacuum is able to skip pages, which are all visible. So I told you about the visibility bit in the the frozen bit in the visibility map, which tells vacuum that all the tuples are visible. So they're all visible. Smaller tables are quicker to vacuum. So partitioning is it's kind of key when you have really, really, really big tables. And Postgres 12 adds this very nice feature, skip index. No, it was, why did I put skip index? I'll fix it right away. It's index cleanup. I was thinking about, I'm not going to even say it. And we're waiting for this. zhip. How do you pronounce it? Zhip? Oh, I don't want Robert in my back saying, hey, that's not how it's done. Zhip is going to be a new storage. Well, actually, it's available already. You can actually download it. Amit says that it performs very well. So, well, we need to test it. And maybe build some nice charts, write a blog. So with zhip, we will basically eliminate everything that we've just talked about. So this talk will be completely useless afterward, if we use that type of storage. So in Postgres 12, we're going to be introducing part of pluggable storage. What part? Yeah. Yeah, table AM. But there's somebody could build something but we're going to have some pluggable storages in future versions. So maybe in 13, 14, and we're going to start having column store, zhip, I don't know, some other somebody comes with some strange idea and it's great, so gets in. So, it means that there's still new features, cool features coming up that can help us a lot. Not only with what I've talked about just today, it helps with a lot of other things. The partition helps with this, but it helps with a bunch of other performance stuff. You see, I went 8.2, 9.6, 10 or 11 for partitioning, 12. Zhip is in the future upgrade. Always try to move forward. It's hard, it's not easy to upgrade, major upgrades, but the end product that you get is really, really good. And just to finish, configure autovacuum, very aggressive. You'll get quicker queries because you have smaller tables, because you're cleaning your bloat more often. So try to get it to do its work very fast. If autovacuum has to work too much on a table, it's all that time that it's working, it's time that your table is still bloated. So make it finish the work as quick as possible. Run preventive vacuuming during low load. Now, the vacuum that I just gave a very short recipe there will also clean dead tuples. So you're actually cleaning dead tuples, freezing, doing a lot of work when nobody is actually using the server, or just a bunch of weirdos around there are using it, and the managers are at their home drinking very expensive champagne. Super important. Monitoring is the key of all this talk. If you have monitoring, the rest doesn't have any sense. You already got the alert. It says run a freeze or run a vacuum or do something. And please, don't set autovacuum freeze max age to something larger than 1 billion. Surely don't set it to 2 billion. You can set it to, I think the default is 200 million. I think something closer to 800 million is okay. If your system is really high on transaction, then 800 million should be enough. Should be a good value. 1 billion is okay. I mean, I will not reject to 1 billion. Above that, yeah, the beer. Well,